BDTH2, Wikipedia article audio. BDTH2 is an organosulfur compound that is used as a chelation agent. It is a colorless solid. The molecule consists of two thiol groups and linked via a pair of amide groups. The compound was reported in about 1994 after a search for chelating agents selective for mercury. It was licensed in 2006 to CTI Science with the long-term goal of using BDTH2 in mercury poisoning. This compound is prepared by treating isophthaloyl dichloride with 2-equiv of cysteamine. Preparation. Use. BDTH2 can be used to chelate heavy metals like lead, cadmium, copper, manganese, zinc, iron, and mercury from groundwater, coal tailings, gold ore, wastewater of battery recycling plants, and contaminated soil. BDTH2 appears to bind mercury more strongly than do other chelators. The mercury BDT complex does not break down even at high pH and in the presence of cyanides, as in wastewater of gold mines. The particular stability of the mercury bond can be attributed to the linear position of the two thiols. The company Covalent Research Technologies had investigated BDTH2 for the removal of mercury from flue gas without success. Animal experiments with inorganic mercury showed that BDTH2 effectively binds mercury in the body, and the resulting mercury derivative is excreted in the feces. Experimental animals showed no signs of poisoning. It is unclear how the BDTH2 mercury chelate behaves in the long term. BDTH2 is lipophilic, as opposed to DMPS and DMSA, and thus can cross lipid membranes including the blood-brain barrier and enters the bone marrow. In animal experiments, the amount of mercury in brain tissue was not increased, but also not decreased. However, there are indications that the BDTH2 mercury compound moves into adipose tissue. It is unknown how BDTH2 works with methylmercury. BDTH2 appears to bind copper and zinc in vivo only weakly. In contrast, DMPS and DMSA bind these ions more strongly. Its affinity is low for other hard ions, e.g. Ca2+, Mg2+, Na+, and K+. Until July 2010, CTI Science sold BDTH2 under the name OSR No. 1 as a nutritional supplement. Since OSR No. 1 didn't fulfill criteria of a nutritional supplement, its sale was stopped under pressure of the U.S. Food and Drug Administration. In January 2012, BDTH2 was designated by the European Commission as an orphan drug, which guarantees CTI Science 10 years of exclusive marketing rights. The US FDA in April 2012 also designated the compound as an orphan drug. Environmental remediation. Like most thiols, BDTH2 binds to mercury salts to form thiolate complexes. In principle, it could be used to remove mercury from water for industrial applications under a wide range of conditions, including the high pH and cyanide of the effluent from gold mining. In industrial use, BDTH2 is easy to make and can be used either as is or in the form of sodium or potassium salts that are more soluble in water. BDTH2 binds to mercury with a strong, nonpolar covalent bond within a water-insoluble organic framework. The resulting BDTHG precipitate is stable, and leaches mercury only under highly acidic or basic conditions. BDTH2 also binds to other elements, including arsenic, cadmium, copper, lead, and selenium. It is effective and economical for removing small traces of mercury from polluted soil, as the precipitate is inert and can be left in the soil after treatment. Clinical use. BDTH2 had been marketed under the name OSR No. 1 as a dietary supplement for treatment of autism. The U.S. Food and Drug Administration determined that BDTH2 is a drug rather than a supplement and issued a warning, resulting in its removal from the market. The main proponent of the compound, Dr. Boyd Haley, was chairman of the Department of Chemistry, where research is also conducted on the utility of this compound for remediation of heavy metal pollution. Potential applications. Dietary supplement and controversy.